Event-driven architecture description. Components communicate through events, enabling asynchronous communication. This is ideal for systems requiring real-time updates and low latency. Use cases, real-time analytics, IoT systems, and distributed systems. Benefits: scalability, flexibility, and decoupled components. Layered architecture description. The system is organized into distinct layers, such as presentation, business logic, and data access, each with a specific responsibility. Use cases. Enterprise applications with complex domains. Benefits: clear separation of concerns, maintainability, and ease of testing. Monolithic architecture. Description: combines all functionalities into a single application that runs as one unit. It's straightforward to develop and deploy. Use cases: small to medium-sized applications and startups with limited scope. Benefits: simple deployment, debugging, and monitoring. Microservice architecture description. The system is divided into independent, loosely coupled services, each focusing on a specific functionality. Use cases: large-scale applications requiring scalability and flexibility. Benefits: scalability, fault isolation, and the ability to use different technologies for each service. MVC, Model View Controller. Description: splits the application into three parts. Model, manages the data and business logic. View, handles UI representation. Controller, connects user inputs to the model and view. Use cases: web applications and frameworks, e.g., ASP.NET, Ruby on Rails. Benefits: separation of logic and presentation, easier testing, and maintainability. Master-slave architecture description. A master component controls multiple slave components, commonly used for tasks like database replication or distributed computing. Use cases: databases, e.g., MySQL replication, distributed systems, and hardware control. Benefits: simplified task management and redundancy.